Hello everyone, myself Professor Chavan. We have started the third chapter from our 11th Science CBSE board for the subject physics. Okay. In today's lecture, we are going to conduct one common and the general topic which we require in any subject. It may you require in the mathematics, it may you require in the chemistry, it may you require in other geography. Okay. So that is the graphs. Okay. Graphs in the kinematics. So what is the graph? ग्राफ क्या होते हैं? What do you know about the graph? Okay, graph is nothing but the pictorial view of the relation between the two quantities. Okay, graph is the pictorial view of the relation between the two quantities. Okay, it may be distance time, it may be velocity time, it may be mass acceleration. Okay, any physical quantity they are having, then if we have to mention the relation between any quantities, then we can use this method of the graph. Okay, so when the particle is in motion, we know that it is changing its position. Okay, it changes its position from one point to another, and along with it, which quantity changes? As we have learned, along with that, the time also changes. Okay, the time also changes along with the position, irrespective of our requirement or not, the time goes on changing. Okay, so in that case, with respect to the position, the time also changes, and if we have to mention the relation between these two quantities, the time and the position, then we can use our table format. Okay, for the one position, how much is the time? For the second position, how much is the time? For the third position, how much it will be the time? Okay, we can note down these things and can represent these things in terms of the tabular format, or even if we can represent them in terms of the words. Okay, we can represent them by our some sentences. Okay, so if the relation between the two quantities is given in terms of the sentences or in terms of the tabular format, then it will be understandable. But more than this, what is the understandable? That if we give the relation between these two quantities by using the pictorial view. Okay, if we give the relation between these two quantities by the pictorial view, then it will be easy to understand. Okay, even if we look at that pictorial view, it will be understandable to us. If we don't have to go for any reading, so by looking at that pictorial view, we can understand how is the relation between the two quantity. Either one increasing and another is decreasing, either both are increasing with respect to each other, either any quantity is decreasing after some time, then it is increasing with respect to the another quantity. These all relation we can come to know by looking at that pictorial view only. Okay, so that's why the pictorial view is the easiest way to understand the relation between any two physical quantities. Okay, even if you go in the mathematics, then there also you have to draw some graphs. Okay, graphs of the parabola, graphs of the hyperbola, graphs of the straight line. So on which basis you are going to draw that graphs, and even if you look at that graph, you can come to know how is that equation of that particular graph, what is the equation of that particular parabola, what is the equation of the straight line. Okay, so if you look at that particular graph, then you will come to know that it is having this particular equation. Okay, so like this we can be easily understandable that if we use the pictorial representation between any two physical quantities. Okay, so that's why if the object is changing its position from one place to the another, then from another place to the third place, then what will happen there? If we measure the length of path for the traveling, then we will get the distance. Okay, if we measure the length of path travel by that particular particle from one place to another and another to the third one, then we will get the distance traveled by that particular path. Okay, And if we have to find out the displacement by that particle, then what we have to do, we have to take the difference between the final position and the initial position, then we will get the displacement. Okay, we will get the displacement. But now what if we have to go for the directions? Okay, what if we have to find out the direction? So for the direction we require one reference. Okay, for the direction point of view we require one reference, because in the world there are the 6 directions, like the east, west, north, south, okay, up, down. So along with these directions we cannot go for the further study, because as the location on the earth changes, the respective direction of that particular place changes. Means from Mumbai the Delhi is in a north direction, but from the Shanghai the Delhi is not in the north direction, it is in the east direction. Okay, from the Mumbai your Chennai is in the south direction, but from the Colombo the Chennai is in the north direction. So as the location on the earth changes, the direction of that particular location changes, because we are considering the direction with respect to the earth's surface. Okay, so that's why whenever we have to go for giving the direction of the particular change in position or the change in position of the any object, then it is the requirement that there must be one single common directions must be defined there. Okay, suppose we have to give the change in position of that particular object, then we have to go for measuring the path traveled by that particular object, then we will get the distance. Okay, if we have to know the displacement, then we can go by change in position from the final to the initial. Okay, we can differentiate, we can get the difference between these two positions and we will get the difference. Okay, but to give the direction of that particular object we need the one reference point. Okay, we need one reference, and for that purpose we have derived one system of the coordinates. Okay, we have derived one system of the coordinates which includes the common systems which are depending on the universal directions. Okay, we have derived the one system, and in that system we have mentioned 3 common directions. Okay, like the x direction, y direction, z direction. Okay, x direction, y direction, z direction. These are the 3 common directions of our developed system. Okay, there later also we are going for the opposite directions, like the minus x axis, minus y direction, minus z direction, because that will be beneficial for us for the further calculation. That's why we are considering here these another 3 directions also in a opposite side. Okay, but generally what is happening there, the x direction is always directed along the horizontal direction. Okay, x axis we may consider at any side. Okay, we may give the any direction as the x direction. Suppose this is the inclined line, then in that case if it is x axis, then here in this may be x axis. Okay, this may be x axis, this may be x axis, but what is the necessary after giving the x axis, that even if the x axis is any arbitrary direction, the y axis while giving it must be a perpendicular, it must be at a 90 degree with respect to the x axis. Okay, it must be at a 90 degree with respect to the x axis. So what is the condition for the system of coordinates, that we can consider any direction as the x direction. Okay, arbitrarily we can go for considering any direction as x direction, but what is the condition later coming is that the x direction is any direction, then the y direction must be perpendicular to that x direction. So accordingly the y direction is always perpendicular to the x direction. So if we show here the y direction, then this will be like this, then here this, then here this. Okay, this. Okay, this may, if it is a x, this is a y. If it is x, this is a y. If it is a x, this is y. If it is x, it is y. Okay, so accordingly we have to give the y direction. Okay, then it comes to the z direction, which is supposed to be 90 degree to both the x and y direction. Okay, the z direction is always at the 90 degree to the x and y direction. Okay, so accordingly the z direction is at a 90 degree to the this or both directions. Then we will write here. Okay, we can give here. Okay, if you draw this plane, in this plane this is the 90 degree, in this plane this is the 90 degree, in this plane this is 90 degree, in this plane this is 90 degree. Okay, here it is 90 degree, then again here it is 90 degree. Okay, it is 90 degree, this is 90 degree. Okay, so what is the condition for the system of coordinates? That we can consider the any arbitrary direction for the x-axis, but the another axis which are dependent on the x-axis, those are y-axis and z-axis. Those two axes must be at a 90 degree to each other. Okay, this y-axis is at a 90 degree to the z-axis, also the z-axis is also 90 degree to the x-axis. Okay, so what is mandatory in this case? That all the axes must be at a 90 degree to each other. And what is the necessary condition for that particular coordinate system is that there must be one reference point. Okay, there must be one reference point. So here this is the reference point and this is called as the origin. Okay, the reference point for the any axis is called as the origin. Okay, so this is the origin for this all the x, y and z axis. Suppose we go for the further details, like if we have to give the direction of the particular point, then in that case which point we have to consider as the reference point? This origin point. Okay, with respect to this origin only we can go for giving the direction of the any particular point. Or if we have to measure the distance from the particular point to the origin, then what we have to do? We have to make one line joining that location of the point to the origin, then it will show us the position of that point with respect to the origin. Okay, it shows us the position of that point with respect to the origin. So these are the system coordinates system. Okay, and this system is known as the Cartesian coordinate system. Okay, this system is known as the Cartesian coordinate system. So if we draw one proper x and y axis, then okay, this is the positive x axis, this is the positive y axis. Okay, then this is the negative y axis and this is the negative x axis. Okay, so here what is important, that the value of the any point along the y axis represents the value of the only y axis. It will not represent the value of x axis. That is, along the y axis the value of the x coordinate will be 0. Okay, along the y axis the value of the x coordinate will be 0. Suppose I have to represent the coordinate like the 2, 3. Okay, then I have to mention that 2 along this x axis only and 3 along this y axis only. And if I don't have the idea of the any coordinate of the any point, then if I draw any point from the passing through the coordinate, okay, if I draw the any point passing through the coordinate perpendicular to that particular axis, then the value of the point along that line will be equal to the value of that coordinate only along that particular axis. That is, suppose if I draw, suppose here is the x is equal to 1, y is equal to 2, then if I draw one perpendicular line passing through this coordinate, okay, if I draw one perpendicular line passing through this coordinate, then any point along this line will represent the value of the x coordinate only. Okay, any point along this line will represent the value of x coordinate only. Along this line there will not be any value for the y coordinate. Okay, along that point there will not be any value for the y coordinate, because if we draw any point along that coordinate, then it will have to show the value of that x-axis coordinate only. Now what is the coordinate? Why I am calling it as the coordinate? Because whenever we go for the any drawing of the any axis or the any Cartesian system, then there are some points are given along that particular axis. Okay, some points are given along that particular axis, and those points along that particular axis are known as the coordinates on that particular axis. Okay, these are given as the coordinate of that particular axis. So 1, 2, these are the coordinates for the x-axis. Okay, 1 and 2, these are the coordinates of the x-axis. Suppose we have to mention the one point. Suppose it is a point is given as point A, it is a 7, 4. Point B, it is a -3, 4. Okay. Point C, I will take here another one. Suppose point 2, 3, 2, point 2, -2, -4. Okay. And D, it is a 3, -2. Then in this case, what is necessary that what is the coordinate, accordingly we have to show the location of this point. Okay, suppose the A point is here and I have to show this A point, then what is the coordinate of this point? It is a 7 and 4. And remember, each and every time what is the first coordinate? That coordinate is along the x-axis only. Okay, the coordinate is only along the x-axis. That is, the first coordinate will represent the x-axis and the second coordinate will represent the y-axis. So whenever we have to show the location of this point from these coordinates, then we have to remember that the first coordinates we have to indicate on the x-axis only. Okay, suppose I will take here as the 3. Okay, I will take here as a 3. Then A 3, 4. 3, 4 means what? Along the x I have to go for the 3 coordinate. Okay, here is the 3. Okay, this is the x. I will rub this. Okay, so if I locate this 3, 4, then again here 1, 2, 3, 4, again here -1, -2, -3, -4, then -1, -2, -3, -4. Okay, so these are the coordinates along this particular x and y axis. Okay, these are the coordinates along this particular x and y axis. Now I have to give the location of this point A, and in that it is given as the 3 and 4. So I have to draw one perpendicular line from this 3. Okay, I have to draw one perpendicular line from this 3. So if I draw this perpendicular line to the axis, okay, so this is the, I have to draw this perpendicular line from this axis. Now the second point is the 4. Okay, so as I have drawn the perpendicular line passing through that point perpendicular to the x-axis, similarly I have to draw a line passing through that point perpendicular to the y-axis. Okay, so here is the point 4. I have to draw one line. Okay, I have to draw one line. Then I will get one meeting point of these two perpendicular lines. Okay, I will get one meeting point for these two perpendicular lines. Then in that case, these meeting points indicate the location of that particular point. Okay, this meeting point will represent the location of that particular point having the coordinates as the 3 and 4. So I can indicate here A is point A, 3, 4. Okay, I can indicate here the point A, 3 and 4. Okay, Now the second point, it is B minus 3 and 2. Similarly, I have to go here again from the coordinate of the x having the value minus 3. Where it is? It is here. Okay. From the minus 3, I have to draw one perpendicular. Okay. Then this is the perpendicular to the x-axis I have drawn. Then here it is the 2. And then I have to draw the perpendicular from the y is equal to 2, which is perpendicular to the y-axis. So here it will be perpendicular to the 2 y-axis passing through the 2. So this point is representing the point B having the coordinates as the minus 3 and 2. Okay. This will represent the coordinate minus 3 and 2. So this is the point B with the coordinate minus 3 and 2. Okay. This is the point B with the coordinate minus 3 and 2. Now the third point, it is C is equal to minus 2 minus 4. Okay. Minus 2 minus 4. Okay. So where is the minus 2? Here. Okay. And where is the minus 4? It is here. So I can draw a line passing through the minus 2 in a perpendicular to the x-axis. So it will be in a downward direction. Okay. And where is the minus 4? So minus 4, I have to draw a line perpendicular to the y-axis, which is passing through the minus 4. Okay. So if I draw this line, then this point will indicate the point C. So it will be minus 2 minus 4. Okay. It will be minus 2 minus 4. Okay. Now if we go for the fourth point, that is the D is equal to 3 and minus 2. Okay, 3 and minus 2. Then in that case, what is the 3? Where is the 3? So this is the 3. Okay, this is the 3. I have to draw one perpendicular passing through this point and perpendicular to the x-axis. And where is the minus 2? The minus 2 is here along the y-axis. Okay, and I have to draw one line passing through this minus 2 perpendicular to the y-axis. So meeting point of these two lines will give me the location of that particular point. So here D is equal to 3 minus 2. Okay, D. I can locate this point as the D is equal to 3 minus 2. So likewise, if we know the coordinates of that particular point, then we can find out the position of that particular point. Okay, we can locate that point, and when we have to find out the position of that point, then what we have to do, we just have to draw one line joining this point with respect to the origin. Okay, where is origin? This is the origin. Okay, so if I draw one line joining these 2 points, okay, if I draw one line joining these 2 points from the origin and the location of this point A, then this line will represents the position of that point. Okay, the line OA represents the position of point A. Okay, line OA represents the position of point OA. So this is the use of the Cartesian coordinate system, and accordingly we can go for using this Cartesian coordinate system for our convenience. Okay, it is the system generated for our convenience. Okay, this is not that any fixed system. We can go for selecting the any direction. Okay, we can go for selecting the any direction. Suppose this is the, if I consider this is the positive y-axis, then the axis opposite to this axis, this direction must be a negative y-axis. If I consider this direction axis as the positive x-axis, then the direction opposite to this axis will come directly as the negative x-axis. So it is not mandatory which direction is supposed to be the positive or the negative, but for our convenience we are considering this as the positive, this negative, this positive and this negative. Okay, so accordingly we have to go for the Cartesian coordinate systems. Okay, so these are the very important points, because we may require this for getting the location of the particular points in at the time of practical. Also, if we go for the measurement of some quantities, then at that time to find out the relation between the two quantities we need this Cartesian coordinate system. We need this graph type Cartesian coordinate system, and then in that case we have to consider the one quantity. Okay, we have to consider the one quantity along the x-axis and the another quantity along the y-axis. Okay, we have to consider one quantity along the x-axis and another along the y-axis. Then we have to go for the further drawing of that particular graph. One more thing is that if the line drawn from the origin to that point is giving the position of that line, and it may give the position in terms of the angle or in terms of the coordinate. Okay, suppose we don't know about the coordinates. Suppose we have a one point here. Okay, suppose we have one point here and we want to find out the coordinates of that particular or the location of that particular point. Then we have to draw one line from this reference point. Okay, we have to draw one line from that reference point. Suppose this is the point P. Okay, suppose this is the point P, then this length OP will represent the position of that point from with reference to that point O. Okay, with respect to our origin. Okay, and if we have to find out the coordinates of that particular point, then we may draw a perpendicular from that point on that particular axis. Okay, if we draw a perpendicular from this point on this x-axis, then we will get the coordinate of that point. Okay, we get the coordinate of that point on the x-axis, and if we draw a perpendicular from that point on the another axis, suppose the y-axis, then we get the coordinate of that point on the y-axis. Suppose we draw a perpendicular from this point on the x-axis. Okay, and also we draw a perpendicular from this point on the y-axis. Then what will happen here, if we measure what is the coordinate of the x-axis at this point, suppose it is a 2.5. Okay, and from this point the perpendicular is drawn along the y-axis, and this is the point 2. Then what is the coordinates of the point P? What is the coordinate of the point P? Remember how to write the coordinate, first x coordinate and then the y coordinate. First x coordinate we have to write down and then the y coordinate. So how to write down the coordinates of the point P? It is the 2.5 and 2. Okay, we can write down it as the 2.5 and 2. Okay, 2.5 and 2. So likewise, even if we don't know about the location of the particular point, or if we have to find out the coordinates of the particular point, then also we can find out the coordinates of that particular point by using our method of the Cartesian system. Okay, for that purpose, what is important, then first we have to know where is the reference point, where is the origin, and which are the directions, either it is the x direction, either it is the y direction. Okay, either it is a negative or it is a positive. We have to make this negative positive as per our convenience. Okay, suppose we are having one particle which is a traveling. Okay, traveling means it is changing its position from the one point to the another. Then if we measure the path traveled by that particular point, then we have the data of that particular point. Okay, for the particular time interval, suppose for the time interval of the 10 seconds, we are considering the distance covered by that particular point along a straight line. Okay, suppose this is the one displacement of the particle along a straight line. Then if we have a data that after 10 seconds how much it is covering the distance, after 10 seconds how much it is covering the distance, then after 10 seconds how much it is covering the distance, then in that case we have to know about this. Okay, how can we know the relation between the displacement and the time? Okay, how can we come to know about the displacement and the time? We can represent this by using some numerical methods or in our sentences also. But if we have the data in a tabular form, then we can go for finding the relation between the displacement and the time with respect to our graph. Okay, by giving the pictorial view of that particular quantities, we can find out what is the relation between these two quantities. Okay, suppose we have one data of the displacement and the time. The particle is changing its position, and we have a data for the each 10 seconds. Okay, in a tabular form we have this data, then this is the position, this is the time. Okay, suppose for the time 0, position is 0, or the 10 it is a 2, or 20 it is a 3, for 30 it is a 4, for 40 it is a 6, for 50 it is a 8. Okay, we have these two quantities. One is the position, or we can say it as the displacement, and second one is the time. So we have here the displacement and the time. So first of all, while drawing the graph, what is the necessary condition is that we have to finalize along which axis we have to show which quantity, and along the which axis we have to show the another quantity. Okay, then after selecting the axis, what is the condition? That we have to select the proper scale. Okay, we have to select the proper scale. So as per our convenience, we can go for the scale. Either 1 centimeter of a graph is equal to 10 second, okay, or 1 centimeter of a graph is equal to 20 second. As per our range of the values, okay, from the higher to the lower, as per our range we can take the scale of that particular. Either it is a 1 centimeter is equal to 10 minutes or 10 seconds. Okay, so likewise this is in a second given, and this is in a meter given. Okay, so if we consider here along the x-axis, here x-axis will represent the time, and y-axis will represent the position, that is the displacement. Okay, then scale we can take is equal to 1 centimeter is equal to what is, okay, you are actually drawing the graph. I am taking just here the one for your information. 1 centimeter, what is the x? It is 0, 2, 3, 4, 5. So I can take 1 centimeter is equal to 1 meter, and along x axis, and 1 centimeter is equal to 10 second along, sorry, this is along y and this is along x axis. Okay, 10 second along the x axis. Now if I draw a graph, okay, if I draw a graph, okay, so what is my condition is that 1 centimeter is equal to 10 second along the x-axis. So I can show here, first of all show the origin. Here it is a point O, and it is having the coordinates 0 and 0. Then 1 centimeter is equal to 10 second along the x-axis, so it will be 10, 20, 30, 40, 50, 60. Okay, how much I required here? Only up to the 50, but I am taking one as a one extra measurement there. Okay, so the next one, 1 centimeter is equal to 1 meter along the y-axis. Okay, so accordingly I have to consider 1, 2, 3, 4, 5, 6. Okay, also name here y-axis, x-axis. Okay, then name it here, and then write down here which quantities along that particular axis. Along the x-axis, what we are considering, it is the time. So write here the time along this direction. Then the position, so write here the position along this direction. Okay, so the time along this direction and the position along this direction. Now locate the points as per the data given. Okay, locate these points as per the data given. So which at first point it is the 0, 0. Okay, first point it is the 0, 0. Then the second point, it is the position 2 at y is equal to 2. What is the position of the x? It is the 10. Okay, it is the 10. So draw a line perpendicular from this 2. Also draw a line perpendicular from this 10. Then we will get one meeting point here. Okay, we will get one meeting point here that will show us that it is the one first point of that coordinate. Okay, suppose give here the coordinates as the 10 and 2. Okay, give here the coordinates as the 10 and 2. Now the second point, it is 3 and 20. So accordingly 3, draw a perpendicular from the 3, then draw a perpendicular from the 20. Okay, so here it will show the 20 and 3. Remember how to write down the coordinates. Each and every time write the coordinates such that first coordinate is for the x-axis and the second coordinate is for the y-axis. Okay, then the third one, it is 4 and 30. So draw a perpendicular from this 4 perpendicular to the y-axis, and draw a perpendicular from this 30. Okay, so here it is a 30 and 4. Okay, it is 30 and 4. Then we are having 6 and 40. Okay, we are having 6 and 40. So we can draw a perpendicular from this 6, another perpendicular from this. Okay, it is passing through, and this point will represent the 40 and 6. Okay, this point will represent the 40 and 6. So according to the positions and the quantities given, according to the measurement taken, we can locate this along this particular graph. Okay, so if we join these lines, these all the lines of the data. Okay, if we join this line, okay, if we join this line, then we come to know that as the position changes, as the position goes on changing, the time also goes on increasing. Okay, because it is a one increasing line, one straight line is there. So as the position goes on changing, the time also goes on increasing. Okay, so as the position changes, the time also changes. Okay, so by this way we can, if we look at this, then also we can come to know that how will be the reading of this particular position and the time. Okay, how will be the reading of that particular position and time. So that the thing we can come to know after looking at this graph also. Okay, even if we look at this graph and we don't have any readings, we don't have these coordinates, we don't have these y coordinates, then also after looking at these points we come to know that how will be the relation between the position and the time. Okay, what will be the relation between the position and the time. Now the next thing, suppose I have to know the reading of the time for the particular position. Suppose I have to know the reading of the time for this here 3.5. Okay, what will be the reading of the time when the position is 3.5? Then what I have to do, from here 3.5, I have to draw one line along that particular line. So it will intersect at this point. Okay, so it will intersect at this point, and if I draw one line passing through this point perpendicular to another axis, that is along the x-axis, then I will get the value of the coordinate along the x-axis. That is, if I know the value of the any physical quantity, suppose I know the value of the position, that is it is 3.5, then what will be the respective value of the time, that I can come to know by using this simple technique. Just I have to draw one perpendicular on that inclined line which we got after connecting the coordinates of that position points. Okay, so if the one physical quantity is known, we can find out the second physical quantity also. Here we know the position, so we can find out the time, respective time. So from this, if we draw one perpendicular here, So here it will be the time. So for the 3.5 we can give here what is the position. Suppose it is the 25 and it is the 3.5. Okay, means even if it is not given in the data, okay, it is not given in the data that for the position of 25, okay, for the position of 3.5 what is the time period, okay, for the position of 3.5 what is the time period, that information is not given here. Then also we can calculate the respective information for that particular another quantity. Here it is given 25. For the 3.5 what is the value of the x-axis, it is the 25, that is the time period will be the 25 second. Okay, so at the time period of the 25 second the position will be at a 3.5. So like this, even if the one quantity is given, we can find out the second quantity by using the graph. Okay, so that's why the pictorial view of this particular physical quantities is very important, because it is no need to go for the any lengthy calculations or no need to go for the any consideration. Just we have to take that values and we can go for the unknown values also. We can get the unknown values there. Okay, so that's why this pictorial view is very important in a physics. While performing the any experiment we have to go for this graph. We have to use this method of the pictorial view by using the graph. Okay, so that's why this graphs in the mathematics is a very important. You must have to know how to draw a graph. Okay, you must have to know how to draw a graph, and if you have the idea to draw a graph for the particular readings, you can directly get the relation between that particular physical quantities. Okay, so that's why this pictorial view is very important in case of the physics.